Here we will discuss about the super tricks of HIO4, that is oxidative cleavage with the help of HIO4, that is periodic acid. So HIO4, see here, this is sodium iodate, NaIO4, KIO4 and lead acetate, that is lead tetraacetate. All these four reagents which can involve in oxidative cleavage, they will do the same type of cleavage. So four reagents can be similar or can give this similar oxidative cleavages in polyhydroxy compound. Okay, and vicinal diols means OH group which are adjacent to each other, they are called vicinal diols. Now two conditions arise. They can be on the same plane or they can be on the different plane. That is, they can be on the same side or on the anti to each other. So only in cyclic diol, both OH groups should be in same plane, that is on the same side, then only the cleavage occurs. Clear to you? What is the essential condition? That both the OH groups should be adjacent to each other, then only the oxidative cleavage occurs. But if OH groups are anti to each other, cyclic diols, then there will be no reaction, there will be no oxidative cleavage. Here oxidative cleavage occurs in case of same cleavage possible. Okay, so oxidative cleavage will be done in this case, and here there will be no oxidative cleavage. I will make cross. Clear? So what are three conditions? Reagents should be NaIO4, sodium periodate, potassium periodate, lead tetraacetate, or this is called HIO4 is periodic acid. So any four of these can be present. This is, I will write down potassium periodate. Here this is sodium periodate. This is periodic acid, iodic acid. Clear? So here lead tetraacetate I have written already. So any one of this will give you oxidative cleavage of vicinal diol. We are discussing especially about the vicinal diols, and those diols which are same side will give you oxidative cleavage. And when the OH groups are anti to each other, although they are vicinal, but they are anti to each other, OH group are anti to each other, there will be no reaction occur. Here I have written, see, if two OH groups are anti to each other in open chain, then oxidation cleavage can occur. Now we are comparing. If it is cyclic, there will be no reaction. If it is open chain, the reaction will occur. Okay, whether OH group are similar on the same side or on the opposite side, so there is no restricted rotation, so it will occur. Here restricted in case of the cyclic diols, there if they are anti to each other, there will be, I will write on the 7th point. You write down till then these points. 7th point, OH groups are anti to each other. In case of cyclic diols. So there is restricted restricted rotation, so no reaction. That I told you orally. Clear to you? So we are comparing open chain cyclic open chain vicinal diol and cyclic diol. They are vicinal, but they are anti, OH group are anti to each other. Then there will be no reaction. Write down all these points. Hurry up. Good. 4 reagents: HIO4, NaIO4, KIO4, lead tetraacetate. They will give oxidative cleavage. We are discussing about vicinal diols. Here I have given you open chain as well as closed chain. open chain, then there will be reaction of oxidative cleavage occurs whether they are on the same side or on the opposite side. Clear? Now see the examples here. See, I have drawn these two structures. Here they are on same side. Oxidative cleavage will occur. From here it will break away. Oxidative cleavage from here. Then 1 OH, 1 OH we are adding extra. Water will be lost and you will get dicarbonyl compounds. 2 CHO group will get. That is 1,6 diol. Diol. Okay, now it is open chain. So hexane 1,6 diol. Because after breaking the cycle, there will be open chain dicarbonyl compound will get. OH group are on same side, so oxidative cleavage occurs. Clear? Now, in this case, see, this is cyclic diol. This is above one is cyclic diol. This is also cyclic diol. This is vicinal. This is also vicinal. These two OH groups are on the same side. They are on opposite side, opposite planes, or you can say they are anti to each other. So, whether we'll put HIO4 or KIO4 or NIO4, then there will be no reaction. Anyone. I have given you all the 4. So, no reaction will occur. So, reaction will not occur here. Now, ester of iodide does not form in the closed ring. So, no rotation. So, no HIO4 does not form any oxidative cleavage. I have written this. But in open chain, this restriction is not there. So, in open chain, they will give you this test. Earlier, we have discussed this. Okay. So, here see, HIO4, I have, here I made a cyclohexane 1,2 diol. Here I have given example of cyclohexane. Pentane 1,2 diol. The same case here, see, these are on the same side. Okay, HIO4. So 1 OH will come over here. 1 OH is already present. 1 OH is provided from HIO4. So water will be lost. Minus water, 2 water molecules. At one go I will write on. So you will get diol. CHO, because the 2 OH group cannot be written on the same carbon, so water will be lost and this bond will coming over here. Okay, so we'll get water. This CHO group will get aldehyde and this is aldehyde. Both of them are CHO group. So 1,5 pentane diol will get. Now see here, this is anti to each other. 2 H groups are anti to each other. HIO4, there will be no reaction. Okay, so OH group are anti to each other. In cyclic diol, vicinal diol, there is no restricted rotation, no reaction will occur. Clear to you? So, we are comparing open chain vicinal diol and closed chain vicinal diol. Thank you for watching. God bless you.